Hello everyone, my name is Yash Parekh. Today I'm going to be speaking about the public switched telephone network. As we know that communication has been revolutionized over the years throughout the use of telephones, and I'm just going to be going over how it's kind of been developed throughout the years. The introduction of the telephone network was such a pivotal point in our lives, as previously we saw data communication to be through computer-to-computer interactions, but now this telephone network has facilitated the ability to use verbal communication, which has been able to allow faster speeds but also remarkable data transmission. Um, throughout the years, there has been various structural changes, as well as various political intricacies where the government has been involved and even tried to eradicate some of the progress that's been made. The hardware of the systems have been developed to kind of better facilitate better networking as well as better transmission overall. Additional components such as trunks and multiplexing, those are all help to facilitate the idea of transmission, as I mentioned before, but also the idea of providing better quality, you know better speeds, better um, range, along with proper switches, which I also will mention later on. But this is basically a facilitation to be able to kind of communicate with others without impacting um, too much data loss. So we're going to begin talking about the structure of the telephone system. Um, so we started having a system where one telephone network was connected to another using a wire. And as the years went by, this was obviously very ineffective as it raised the dilemma of improper connections. Um, so it was ineffective as it was scaled larger. This is kind of a diagram as you see how the kind of intricacies worked when these networks were scaled up. As you see in the letter A, it's just a whole jumble of things as people want to talk to each other. So we kind of there needed to be like a central root to this. So to combat this issue, a system was implemented utilizing switches. So where a user would call an operator, which would then connect the user to the designated callee. This problem was only solved on a small scale, so a new problem arose when users wanted to call others from longer distances, let's say. Um, to solve this, so to solve this, second level switching offices were created to create lower level switching offices to each other. So if you want to call someone from another city or another state, you'd call an operator, which then connects you to another operator, which connects you to an operator of the nearby location of whoever the designated callee is. And this, as time went on, this scaled higher and higher until the hierarchy changed to switching offices to be up to 5 levels. As you can see, this is a little diagram of what I just kind of explained, the kind of process that it would take to reach a designated callee in this instance. Although this was a revolutionary concept and it provided great value, there were political issues that tied into it. In the 70s, the US government deemed this was an illegal monopoly and essentially just shut down um, the whole project, causing AT&T, which was actually the number one um, provider for telephone services, to be divided up into various sections. I believe it was 163 different components. Um, you know, this kind of spiraled on, and this ended up causing the implementation of LATAs or lattice, which were also acted causing further issues. So the lattice were essentially just spanned a whole kind of area, which we kind of notice as today. It would span an area code worth of things, and the IXCs would essentially contact those lattice when telephone services were used. So further issues were actually present after this. IXCs were forbidden to offer telephone services, and the LECs were forbidden to offer interladder telephone service. Um, Although there was kind of the idea when used together, it would cause better service and lower long distance rates at the cost of increased prices for local service. It was something that was kind of not just taken away from the government, but developed. This eventually Congress to draft a bill that allows cable TV companies, local telephone companies, long distance carriers, and mobile operators to enter one another's businesses. So now we're kind of moving over to how it's facilitated, how telephone communication has been facilitated over the years. The essential goal for a modem is to send bits. So when one communication channel is communicating with another, it's essentially sending bits over a loop and any other physical channel for that matter. So what the modem does is it converts these bits into analog signals, which can then be transmitted into a channel which can be used for communication purposes. Um, and then as technology advances, the cable TV industry was offering much higher speeds than we saw in the telephone industry. So to combat this, we see the XDSL, which was used to provide higher speeds. This was done by using a different switch that did not have any cutoff filters for the amount of hertz it translated. Um, so yeah, and then we move on to the ADSL line, which is essentially a line that can be used to enable faster data transmission over copper telephone lines than a conventional voice band modem can provide. We then see the fiber being introduced, which provides faster and better network speeds and services. The optical fibers are installed from the individual homes all the way to end offices. So it provides more of a one-to-one kind of network facilitations. This is kind of a basic understanding of how the modem works and how it's kind of translated into whatever it needs to be translated to in order to be received by computer server, whatever. Um, and then we move on to trunks and multiplexing. So essentially what the trunks are is they essentially carry thousands, even millions of calls simultaneously. This sharing is important for achieving economies of scale, since it costs essentially the same amount of money to install and maintain a high bandwidth trunk as a low bandwidth trunk would between two switching offices. Um, so to be able to capture the information that is received from the telephone channel, as we saw before when we used it with the modem, the end office used a device called a codec, which essentially digitizes the analog signals it receives. So we also see a type of multiplexing being used in the time division multiplexing, which is essentially used to carry multiple voice calls over trunks by sending a sample from each call every 125 milliseconds. Another type of multiplexing, which is a wavelength division multiplexing, which helps to increase bandwidth by multiplexing multiple optical carrier signals onto a single shared fiber for transmission. And here you can see a few diagrams. So for the wavelength division multiplexing, you see there are four different fiber spectrums. Once they're combined into one, you see the bandwidth can immediately become increased as the microseconds grow up and the power goes up. Similar to this, the time division multiplexing kind of uses that same rule of thumb, being able to harness multiple voice calls, so there's less loss in value and speed. So to minimize any errors in the conversion and provide a smoother calling experience, they use this logarithmic scale, which is used to give relatively more bits to smaller signal amplitudes and relatively fewer bits to large signal amplitudes. So by doing this, the error is proportional to the signal amplitude. So this is kind of the idea of multiplexing and just essentially reducing error in incoming waves. So that's all I have to say about this topic. Thank you very much.